So I'm going to try to do a little video that will do some of the notes from today. Today is Tuesday, September 22nd. So maybe it'll go through and clear some things up that didn't get to in class well enough or didn't get to. So there's two types of questions that deal with manipulating a function like f of x. So one would be in words: create a new function g of x that dilates f of x vertically by a factor of 7, shifts it to the right, and then shifts it up 9. So we've got three different parts to this, and we're going to do all of them. Let's do one at a time. So the first thing is we're going to dilate by a factor of 7. So the first thing I'm going to do is I'm going to multiply the whole mess by 7. That would be multiplying the whole function f of x by 7. That's an absolute value there. And then the next thing says it's going to shift it to the right. I didn't say how much it was shifting to the right by, so we have to say shift to the right 4 or something like that. I needed to put that in there, but I did it hastily. So this one is to the left 3 right now, so going to the right would mean subtract 4 just from this part in here. So I'm going to say minus 4 inside that absolute value thing, because that's going to shift it 4 to the left, or 4 to the right, because x minus 4 would be 4 to the right. So that does that. And then after the whole thing is over, we want to shift it up 9. So I got to add 9 at the end. So you might say, well, this is fine. This is our new function g of x, so we're good to go. It would be nice to simplify this just a little bit, because there's some stuff that can happen. First of all, we can distribute this 7 over the different parts of the function. So we have negative 14, absolute value of x minus 1 when you combine those two. And this 7 times the 6 would be negative 42. And then the plus 9 goes at the end. Then I can combine those to make negative 14, absolute value of x minus 1, minus 33. And that would be our final answer after taking this function here and shifting it, or dilating it by a factor of 7, then shifting it to the right 4, and then shifting it up 9. So that's with words. And that's an example of that. And there's some stuff like that on your assignment. Then we have another way of doing these things too. And this would be making a new function g of x by just using a functional notation. So in this one here, what's going to happen is we're going to take this thing inside and we're going to replace it for x. That means we're going to shift this to the left 7, and then we're going to subtract 1 after we're all done. So this one might be easier. We take negative 2. Instead of x plus 3 in the absolute value, it's going to be x plus 7 plus 3, minus 6 from the original problem, and then minus 1 from our new problem that says we're shifting to the left 7 and down 1. So here we go. We can just simplify inside here. Of course, that's x plus 10 minus 7, g of x equals, and there it is. So those are the two types of problems that deal with functional notation and in written words about how you can see what's going on. Now, today in class, I was trying to do this this business about looking at Desmos, and you have a Desmos activity that you could play around with and see what's going on with these things. And what I was hoping you would notice on this thing is that if we look at just the x-intercepts, this one is at 4, whereas this one is at 2. And this one is at 1. And that there's a reason for this, and that's what I was going to be talking about. So this one over here has a vertex at 8, and so forth. And they're different. They're not as, some are wider than the others, and so forth like that. So what I was hoping to get across with that, if you look at the vertices, you'll find that if we rewrite these things so that we're distributing out the b value, so that instead of being in this current form, we have b times parentheses of x minus h. That way you can see that shift much easier, more easily, I should say. So this one, for instance, if we took out the 2 from 2 and 4, we would have x minus 2 quantity squared. And then you could see that it's horizontal dilation by a factor of 2, which is really 1/2. We'll see that in a second, which is a shrink. And this one is going to the right 2. This one, if we take out the 4, we end up with seeing, wait a second, where's the print? Where's the squared business? That's on the outside. Sorry about that. And this one, we see that 4 is the dilation and x minus 1 is the shift. This one over here, if we take out a 1/2, we end up with x minus 8. The whole thing squared. Getting a little rambunctious with my squaring. All right, so we can see this one's 8 units to the right, and likewise this one, 1/4 of 16. This would go all the way to 16, and I can't see the one that's underneath there. But with this negative x in front, it means that it's flipped over the y-axis. We know that if we negate the y values, it's going to flip it over the x-axis. If we negate the x-axis, the x value, it's going to flip it over the y-axis. All right, I can talk. So let's see. I had presented this idea in some of the classes. I got into this and some didn't. So that's about vertical stretches. This is what we already know. Y equals a times f of x is a vertical stretch. And we know that sometimes it makes it stretch further from the x-axis and sometimes it's closer to the x-axis. We're going to have horizontal stretches and shrinks now, where you can see, like the last problem, we've got this a value right next to the x. And when it's inside the parenthesis with the x, or inside the absolute value, or underneath the square root with an x, or whatever it is, if it's grouped with the x, it's going to be horizontal. So what this ends up doing is it shrinks the thing by a factor of 1, stretches or shrinks by a factor of 1 over a. And I think we'll see that much more clearly when we do some tables. So it multiplies the input by a before evaluating the stretch horizontally away from the x-axis when a is between 0 and 1, and shrinks the graph towards the y-axis when a is greater than 1. So once again, that says when a is between 0 and 1, right, it stretches the graph horizontally away from the x-axis when a is between 0 and 1. That's the ax part. And it shrinks it when a is greater than 1. So like when we had 2x or 4x, that shrunk it this way towards the y-axis, or went that way. So it was at 4, and then it was squeezed that way to the right. We'll see this better when we try some problems. So let's see what happens if I go and try a couple of these problems with you. And I would suggest you might want to pause and try these. These are on slides. They're on Classroom under materials, and you can try them before I do them if you'd like. That makes sense. So a horizontal shrink of f of x by a factor of 1/3. Remember, there is that reciprocal business. So if it's a, that's a factor of 1 over a. So if it's a factor of 1/3, that really means what they're saying is the absolute value of 3x minus 3, because it's the reciprocal that we're doing with when we're talking about a factor of 1/3. Vertical stretches by a factor of, I can't see what's underneath. A silly picture. I don't know if I want that there or not, but what happened? Let's go back to that and put that back in. The vertical stretch of f of x by a factor of 2. So that's like 2 of f of x. So that means that our new function h of x is just 2 times the whole thing, x minus 3 minus 5. And we can distribute that too. By the way, if you're wondering, this one is f of 3x. So wherever the x is, I put a 3x. For this one, it's 2 times the whole thing. So 2 times the whole thing would be 2 times the absolute value of x minus 3 minus 10, distributing. Let's see. Try these 3 before I do, and it'll help you if you try them before I do them. All right, so I hope you've unpaused. If not, you still have an opportunity to pause. So this one here says f of x. We're going to translate 2 units to the right. Our new function g of x is going to be 2 units to the left. Now, I need to do it like this, because otherwise I would have the same problem as the original set of problems without the parentheses. If you don't have the parentheses in there, you can't tell exactly which way you're going or how far. So, and by the way, I would say that this is f of x minus 2, or x plus 2, right? So f of x plus 2 has got a new name, it's g of x, and it says move 2 units to the left. This one says translate 6 units down. I don't know, maybe I should use the thinner pen, maybe it'd be easier. 6 units down, so that's going to be f of x minus 6. Our new name is g of x, and I'm going to take, and the only thing I'm going to change is the minus 1 part, so the absolute value of x plus 9 minus 7, because it went down 6. And I know you can do minus 7, minus 1, minus 7, minus 1, minus 6 in your head. This one goes 7 units down, so it's going to be f of x minus 7. So our new name is g of x. So negative 2x, and 2 minus 7 is minus 5. So I hope those worked out. The first one, important about that parenthesis there, if you don't have it, it's going to be wrong, because 1/3 x plus 2 is not going to be correct. You can try it in Desmos, and you'll see that it's not the right one. Let's see. Try these as I pause and try these first. All right, reflecting over the x-axis. Now, the x-axis would be vertical. So this is the same thing as saying it's a vertical dilation by a factor of negative 1. So really what this is asking is, what's the opposite of f of x? Which is minus 1/2 x plus 8, where this is in parentheses. Or if you want to do it in one step, it would be like this. Negative 1/2 x minus 8. And that's the way that one works. Reflecting over the y-axis, now we know that when we reflect over the x-axis, it affected the y value. So if we're going over the y-axis, we're affecting the x value. So this is the same as saying f of the opposite of x. So the only thing I'm going to change here is that it's going to be the opposite of x plus 1. There we go. A vertical shrink by a factor of 1/5. Remember, vertical stretches and shrinks don't make a reciprocal, so we're just going to do 1/5 of f of x. 1/5 of f of x means 1/5 of negative 5x, which is just the opposite of x, because 1/5 times negative 5 is negative 1. So check your answers. You can pause whenever you want. That's the beauty of a video. All right, I think this might be our last one, but I think there are some other type of examples after this. Let's see. So this says a vertical stretch by a factor of 4. So that'd be 4 f of x. You might, if you haven't paused, you should pause before I do these so that you get the benefit of it. 4x plus 3 plus 2. So 4 absolute value of x plus 3 plus 8 if you distribute it out. Horizontal stretch by a factor of 6. That means a reciprocal. So f of 1/6 x. So everywhere there's an x, I'm going to put a 1/6. So 3x becomes 3 times 1/6 of x minus 9. That's how you do horizontal shrinks and stretches. 3 times 1/6 is 1/2 x minus 9. And the last one here, horizontal shrink by a factor of 1/4. A 1/4 means multiply the x values by 4. So it's the same as saying f of 4x. So I'm going to put a 4x where the x is, the opposite of 8 times 4x minus 4, which is also the same as saying the opposite of 32. Oh, that minus is supposed to not be on the inside, is it? Sorry about that. So 32x inside. Cooperate. All right, 32x inside minus 4. So I hope that these are a little more familiar. You can look through the examples again and make sure that they make sense to you. I also have filled out notes on online as well in your Google Classroom. So let's see if these make any sense to try. Let's see. This one says, Write a function g whose graph of a reflection of x over the horizontal stretch of factor of 3 and a translation of 5 units down the x-axis. How about if I take a look and let's see, we can wait on that one. We don't have to do it now. So in class, I'm going to ask you these questions, identify each of these transformations, because I think that this would be a helpful thing to be able to understand what these actually mean in words. So I'm going to go through one of these examples, although let's wait for class, because I think that this is not what I'm asking you to do in the assignment. So that's just fine. Now, if I can figure out how to get out of this thing, I will do so. All right. And I will stop.